So, okay, let's start factoring polynomials. So, do you guys remember when you would do the, what is it called, the square method for factoring? The box method.
Oh, yeah.
So, you would have a polynomial like this. I'm going to zoom in actually. Okay. So we're going to factor a quadratic function. And say we had 6x squared plus 5x plus 1. So how would you factor that using the box method? Yeah, so you would make your box like this. And we would put 6x squared here, 1 in the bottom one. So you would, well, you would then need to go 5x plus 1x, right? And now we would have, what can we factor out of this bottom row? A 1. What can we factor out of this top row? X. What can we factor out of this? And what about this one? 1. Well, that's not right. What did I do wrong?
Isn't it it's 3 and 2?
Yeah.
Oh, okay. So this is the first time I've learned this method, so this is the first day. 3 and 2.
Because they got weighted. Negative.
No, no.
How do you get 1?
I think it'd be.
But they gotta add together.
They have to add to 6.
Don't they gotta add the middle times to the outside?
So you multiply 2, so you multiply 6 times 1.
Oh yeah, and then it's gotta times to that.
Okay. Okay, let's try that again. What are our factors for that bottom row? What can we factor out? What's the greatest common factor? What's the greatest common factor for the next row? What about this one? Okay. So our factors are 3x plus 1 and 2x plus 1, right? And then we can set that equal to 0 and we can find where crosses the x-axis. So today, we're going to be learning a little bit different of a factoring method. So that's factoring, but it only works for quadratic functions. So functions to the squared power, okay? With the highest degree of a 2. So today we're going to learn how to do functions. So this is our first example. And we're going to learn how to do something like 3x cubed plus 7x squared plus 4x. Okay? So we can't use the box method on this one. So we're going to learn this method called grouping, factoring by grouping. Okay? So the first step to grouping, factoring by grouping, is to take the greatest common factor that we possibly can out. And each of these 3 terms have an x, so we can right away just take an x out of there. So we're left over with 3x squared plus 7x plus 4. Okay. So now I have 2 pieces. I have my x. This is already factored out, so I have to leave it there. And now I have this piece inside of my parentheses. Well, now that looks like something that we've seen before, and we can factor that piece using the box method, can't we? Because that's a quadratic function. So let's try doing it. So I would have to start in my upper left corner, 3x squared, and my lower corner. And now what would my other two boxes? Because those add up to 7x. So now let's do our little spaces here. So what can we take out of the very bottom one? 4. What about the next one? So next. What do the next two have in common? 1. So, well, I have to keep that x there because it's already factored. Now I can break that next piece up into my new factors. Times x plus 1. And we factored that all the way. And since that original function was to the third power, I have 3 factors. So it's going to cross the x-axis 3 times. So it's going to cross, if we set this equal to 0, where would it cross at? Because you could do x is equal to 0, negative 4/3, and negative 1. Okay? So let me see if you totally get that, kind of get it, or don't get it at all.
I'd be able to kind of.
Okay.
If it's a constant value.
Like which?
There's like a whole number, so it's like 3x cubed plus 7x squared plus like 4.
So it's not whole. It's not a lot different. So we're gonna do an example like that. Okay. So the first step is always factoring out our greatest common monomial. So remember when we learned what the monomial was? Something like 3x or 4x squared or x. So for example, we took out the greatest thing that we possibly could as the first step over here. So we could take out that x, right? So the very first step to factoring. So let's look at this example, 2x cubed minus 20x. So this is a little bit different, huh? So what can we take out of this? What's the greatest thing we can possibly take out? Yep. Does everybody see why we can take out a 2x? So what would be left over?
X squared. X squared minus 10.
Yep. So is that all the way factored, or can we factor further? So if I were to set this equal to 0, it would be x squared is equal to 10. Square root both sides, and I have x is equal to plus or minus square root of 10, or plus or minus 10. Did I write that wrong? Yeah. It's supposed to be minus 20. So we were left with a square root of 10, and if we're factoring, that's not what we want. We want whole numbers. So that's as far, this right here is as far as you can go, because I don't want to have a square root of 10. I don't want an irrational number as a factor. Like on the area one, I just have nice whole numbers, so that's what we're looking for. So you would stop at x minus 10, x squared minus 10. Okay, so do you guys remember the warm-up? We talked about factoring patterns, okay? So we've already learned a couple of them. We've learned, and this is for your notes, so we've learned the difference of two squares, so we've got that one down. We've learned perfect square trinomials. We've got that one down. So there are 2 other factoring patterns that we will need to factor all the types of polynomials. So the 2 that we haven't learned are the sum of 2 cubes and the difference of 2 cubes. And remember that these notes are going to be online on the website that you can check at home or in the library or whatever on your phone. We're going to post the video. Okay, so let's try example 2, factoring polynomials using our factoring pattern. So do you remember for the warm-up how I said we need to know the factoring patterns to do 6.4 today? So this is where we're going to use those patterns. So that's why I kept saying how important they were and stuff. So part A, we have 27x cubed plus 64. So we're looking for a factoring pattern within these, okay? So I have 27x cubed. Well, I know that's already cubed, but I want to see, can I take the cubed root of 64?
4 times 4 times 4.
Yep. So it's equal to 4 cubed. That's the same thing, right? So if I want to use my factoring pattern that we just learned, this one, a cubed plus b cubed, can I write this problem in that form? So if I have 27x cubed and I want to write it, I would go like this. I would go 3x cubed plus 4 cubed. And this is my a and this is my b. So it's kind of like that homework that we were doing that you guys had questions on, the number 18 on the homework, where I had that number and I broke it down using my factoring patterns. It's the same idea. So then once we know that, we can use our a and b and plug it into the pattern to find the answer. So what would my a be in this case? 3x, and my b would be 4. So what they're doing is they're just plugging in the a's and the b's and making sure to use parentheses, because if we're squaring stuff like 3x, it's going to be 3 squared x squared. Okay, so let's try an example. So let's look at number 6, 40x to the 4th plus 5x to the 5th. What would be my first step? Remember what we learned? The very first step is taking out the greatest common factor.
5x.
Yeah. So the first thing I'm going to want to do is take out my 5x. Well, what would be left over? 8x cubed plus 1. Okay. So, well, I can't use the box method because it's a cubic. It's not a quadratic. So, could I use a factoring pattern? Well, I know that 8x, well, this is just 2x quantity cubed, right? Yeah. And then 1, I can just write 1 cubed. And this whole piece is times 5x. So now I can use my factoring pattern. And my factoring pattern was a cubed plus, what was it? Yep. Is equal to a plus b times a squared plus ab plus b squared. So this is, if you guys remember, this is the perfect square trinomial. So it's just the perfect square trinomial times a plus b. So now we have our a, we have our b, and we can plug it in, but make sure to not forget the 5x. So it would be equal to 5x times 2x plus 1 times, plug my a in, 2x squared plus 2x times 1 plus 1 squared. Okay? So let's just reduce this a little bit. 5x times 2x plus 1 times 4x squared plus 2x plus 1. Okay. What do you guys think about that? Are we done or can we keep going? Well, now we have a quadratic. So could we use the box method and see if that one factors any further? Okay. So this is factored, this is factored. Let's make sure this one's fully factored. So if we did the box method, this would be like, what will go in that top corner? 4x squared and 1. And what would be in the next two?
2x.
Are there... I don't think we can go any further. I think that's as far as it goes, right? Because the box doesn't work, so then I know it's fully factored. Okay. Is everybody okay with that one? Yeah? So we just gotta kind of keep working through all those pieces. Once you find the first factor, then you look at whatever's left over and see if you can keep factoring it until it's completely factored. So factoring by grouping, that's kind of what we already talked about. So if we had this example, x cubed plus x squared plus x plus 1, x cubed plus minus x squared plus x minus 1. How could we group this so that we could factor out the greatest common factor? So I'm going to do x cubed. Can I rearrange these terms however I want? Could I go like x cubed minus 1? Or could I not? Is that not allowed? I can do it because addition and subtraction is commutative, so it can move. So if I go x cubed plus x minus x squared minus 1, is that against the rules? No. So what if I go take an x out of this first piece? What would be left over? If I just took an x out of that very first piece.
X squared plus 1.
Yeah. And what if I took a negative out of this piece? Okay. So, oh, this is interesting. So what I have now inside of these parentheses, are those the same? So, yeah. So this is the key to factoring by grouping. Once you have the two pieces the same inside of the parentheses, this is what we can do. This is our little rule. So what's technically in front behind this negative? There's a 1 there, right? So let's pop that 1 in. So we can write this, group this piece and this piece together. We group those, so we get x minus 1, okay? And then once we group that, we can just group one of these pieces and we get x squared plus 1, and that's how we factor it. So that's factoring by grouping, okay? So let's just look at that one more time. So all I did was rearrange my terms so that I could find this piece to be the same. So I took x cubed plus x, so I just moved that piece over, then I subtracted my x squared, and then I subtracted 1. Okay? Then I factored out an x, factored out a negative 1 so that I had the same terms inside of the parentheses. And then you write your x minus 1 and you group it, and then we write that one time. And how can we make sure that's equal to the original function? Yeah, we could FOIL that out. So we get x cubed plus x, oops, minus x squared minus 1. Same as we started with, right? Or minus x, what did I write? So x cubed plus 1x minus x squared minus 1, which is what we had at the beginning. Okay? Do you guys want to do one more of those? Factoring by grouping?
Yes.
Okay. So we'll do this last one and then I'll hand out your worksheets. Okay, so how can I rearrange this one, do you think? What was it? Yeah. So you never really know where to go when you start. So well, I like that both of these have a 3x in it. So I'm gonna start by rearranging those together. Plus 3x plus x cubed plus 2. Okay, so I grouped those 3 x's together. So I'm gonna take the greatest common factor out of that piece, which is 3x. So x plus 1. Okay. And then I have x cubed plus 2 left over. Could I take anything out of x cubed plus 2 other than 1? I can, but I can take a 1 out, right? So if I have 3x, x plus 1, I'm going to just factor out a 1. X cubed plus 2. Oops. So then that grouping thing only works when we have the same number inside of there. So do we have that same number? No. Let's try something else. So what was your original one, Alyssa? What did you say? Oh, okay. So let's try something else. Let's try taking an x out of this piece. So let's factor out an x squared out of this. And we have an x plus 3. Okay. And then what could we take out of that one? Plus 1. We still get a 3x plus 2. So what do you think on this one? Let's try, we still have one more option, right? X cubed plus 2. Or did we already try that one? Mrs. Nolte, do you see how you can group this one? X cubed plus 3x squared plus 3x plus 2?
It's impossible.
No, I don't see it.
Me neither. X cubed. Dawson, do you see this one? We can start on this one after. Well, what if you did and took an x out of this entire piece? x squared plus 3 plus 3x plus 2, and then add up to 3. No, you can't. Okay, well, we'll come back to this one. But, okay.